All right, so take a look. It's a word problem with a chart, right? And we like charts because the chart gives you whatever information you need in order to solve the problem. I will read it to you. Now suppose a bag full of 450 grams of ice at 0 degrees Celsius sits on the counter and starts to melt to liquid water. Still at 0 degrees Celsius. So in other words, has the temperature gone up?
No.
How much energy or heat is absorbed as the ice melts? Now you're going to have to look at this chart and figure out which of these four values you need. Now, we also have some givens. Circle your givens. 450 grams, what kind of given is that? What is the variable for that?
Mass.
That's mass, or M, right? G is grams, grams is mass. So all of these variables have a letter, like mass is M, right? And they also have a unit. So the unit for mass is grams. Okay? And then I'm looking in here, and if I'm thinking to myself, gee, I've got these two temperatures. Whenever I give you two temperatures, usually what do you have to do with it? Usually you have to subtract. But what do you get when you subtract 0 minus 0?
0.
0, right? So this is weird, because I'm thinking to myself, okay, Q equals mCp delta T, right? And do I have Q?
No.
No. In fact, it says how
Much
much heat or energy, right? So Q is my unknown. Okay, that must mean that I need my mass, my Cp, and my delta T, right? So my mass, that's easy. Mass is 450 grams. Cp, okay, do I need the Cp for ice, solid water, or do I need the Cp for liquid water?
Liquid water.
I don't know. I'm actually leading you down the wrong path because I want to show you something. I'm not sure which Cp I need, right? It's either this one for ice or it's this one for water, but the ice is melting, right? So it is solid and then it's becoming liquid. So which one do I use?
Liquid.
I don't know. Liquid is the one I have always used, right?
Yeah.
So I might be thinking to myself, oh yeah, 4.184, that's the number that I recognize, right? So if I'm thinking to myself, okay, 4.18, great, okay, fine, right? Weird units. But here's the problem. My delta T here is 0 minus 0, which is just 0. Okay. So if I'm trying to find Q using this equation, and I start plugging numbers in, it would be Q equals 450 times, okay, I'm just going to use the number that I recognize, right? Times 0. What do you get when you multiply anything times 0?
0.
0. So basically what you're saying to me is that Q is equal to 0 joules? That's not right. Because we know that melting things takes energy, right? Melting is an endothermic process. You have to put energy in, right? Okay. So it can't be correct. It's not 0 joules. If it's not this one, is it this one?
No.
Wait a minute, wouldn't I run into the same problem if I used the Cp for ice?
Yeah.
Because if I just change the 4.18, if I change that to 2.1, I'm still going to get 0, right?
Yeah.
It's not that.
Oh.
Okay. Now, these other values are my delta H, my latent heat of fusion, my latent heat of vaporization. Which one can I eliminate here because I'm not vaporizing it?
HV.
It's definitely not this one, right? So it's obviously going to be this one.
Fusion means.
Fusion means melting. It's the old-timey way of saying melting, right? So the latent heat is the energy it takes to melt something, right? But it's the energy that it takes without raising the temperature. Remember, when you melt something, the temperature stays perfectly flat, right? Stays the same. So it's the heat that has to go in when the temperature stays the same. And if you look, our temperature is staying the same, right? It's all at 0 degrees because that's the temperature that water melts. So here's what you do. And guys, by the way, this is just like that other homework that I gave you, where I gave you 5 questions. They all had to do with latent heat, and they all were just multiplication problems. Okay? So what you do is this. Q equals delta H fused times the mass. Or another way of saying that would be the mass times the delta H fused. Right? I just switched the order. Right? I probably should have written it that way the first time. Go ahead.
So that would be the formula every time.
Whenever we're actually melting things. Right? If you look, this is joules per gram. So every 1 gram takes this many joules, right? How many grams do I have total?
450.
450, right? So 450 grams, each one takes 334 joules. All I have to do is just multiply, right? That's equal to 450 times 334. And that's what I told you to do on that worksheet, was just multiply, right? Just multiply the delta H fusion times the mass. Now, this is not something that I asked you on the test, or that I'm going to ask you on the test, right? But if you take a look at this equation right here, Q equals this, and you think about Q equals mCp delta T, right? We couldn't use this one because delta T was 0, right? But if you look at this delta H fusion part right here, and you look at this part right here, those two equations are basically the same, aren't they? Q is equal to the mass times this other thing. The mass times these other things, right? The specific heat capacity, Cp, is the amount of energy it takes to raise the temperature of something by 1 degree. So if you raise the temperature of something by a bunch of degrees, that's how much energy it takes to raise the temperature of it by that many degrees, right? This delta H fusion is the amount of energy it takes to melt all the ice for 1 gram. If you multiply it by how many grams you have, that gives you the total. So these two equations are basically the same. It's just that one is for melting, which is a phase change. The other one is no phase change. It's just raising the temperature of a solid or a liquid or a gas.